Hello students, how are you? I hope you all are doing fine, no? So this is going to be our next part. This is the part 5 of the lesson motion. Okay. Today I will start from the actually last thing that we actually ended. Okay. Our today's topic is going to be graphical representation of equation of motion. Okay, this is nothing but the graphical representation. In the last class we have actually discussed how we can actually graphically represent, right, velocity, speed and acceleration, right, in the distance time graph, velocity time graph and the acceleration time graph. Today we will see there's a new term actually there, equation of motion. First we will actually look what is actually equation of motion, then after that we will represent them graphically. Okay, so this is our today's new topic. Now first we have to see what is actually equation of motion. Okay, now first we have to actually understood, okay, that what is actually equation of motion means. See, whenever an object actually moves in an uniform acceleration, okay, an object is moving, that means uniform acceleration means what? Its velocity is changing at a uniform rate. If there is no velocity increase, there will be no acceleration. That means if the velocity is constant, there will be no acceleration. If there is uniform acceleration, don't get confused about that. If there is uniform acceleration, there is a velocity increment or the increase of velocity at a certain rate of time, but that increase is uniform. That is, if the acceleration is 2 meters per second, the velocity will be 2 meters per second. Then after that, after 10 seconds, it will be maybe 4 meters per second. And after that, again 10 seconds, it will be a 6 meters per second. So it is like that. Whenever an object moves at a speed of, consider one car, okay, this is a car. It is moving from A to B, then from B to C at a uniform velocity rate. 2 meters per second, 2 meters per second, right? At 10 seconds, and then 20 seconds. It is like that. This is the uniform acceleration means. Now we are considering that if a object is moving at a uniform acceleration, then we can establish relations, okay, between velocity, acceleration and distance, okay, with certain set of equations. Okay, we can establish a relation between this velocity, acceleration and distance with certain set of equations. Those relations are known as actually equation of motion. Okay, equation of motion. Those relations are actually known as equation of motion. Now how those actually equations are, okay, we have to actually check. There are basically 3 equations of motion. Okay, first I will erase this part. The first one is known as the P equal to u plus at, right? This is nothing but the velocity time relation. I will not write the word relation. Okay. Next one is nothing but s equal to ut plus half of at relation. Half of at square, sorry. Is equal to half of ut plus half of at square. This is nothing but the position time relation. Okay. Now the third one is twice as equal to v square minus e square. This is nothing but the position, okay, position velocity relation. Okay, these are the basic 3 relations that we are going to need as equation of motion. Okay, and remember one thing, in your exam maximum questions comes from these 3 equations. Okay, we'll actually discuss about the problems. Those are quite interesting one. Don't have to worry about anything. Quite simple. I will make it simpler for you. Don't worry. First we will actually see how we can prove this. Okay, we can prove this with 2 ways. First one is without using any kind of graphical representation. Our topic is graphical representation, but I will again show you how we, without using graphical representation, we can actually prove this. Okay, first after that we will move towards the graphical representation of the equation of motion. Okay, first I will prove this first one, v equal to u plus at. Now I will erase this thing and I will prove the first one. Now I will first prove without using graphical representation. Okay, our first one is going to be v equal to u plus at. This is nothing but a what? Velocity time relation. Okay, velocity time relation. Okay, how will you start? Okay, we have to use some our from our concept. Like we know acceleration A equal to v minus u by t. Simple concept, we know that. So if I multiply A with t, what is going to be there? A into t equal to v minus u, right? That means nothing but at equal to v minus u. We need the relation as v in the left side, or you can say right side, and u plus at in the other side. So I will again actually bring minus u to here. Then what will be there? That minus u will become positive. At plus u equal to v. If I arrange this one, it will be like v equal to u plus at. We have got simple. Okay. If there is a question in your exam that prove this thing, okay, and it is given only 1 mark, you can actually do like that. Okay. This is the thing. Now, if it is more than 1 mark, then you have to do the graphical representation. Clear? Now we'll move towards our next relation, that is nothing but the position time relation. Okay. I will actually again write 2, 1. Number 2 is equal to be s equal to ut plus half of at square. Okay. This is nothing but the position time relation. To start this, what we have got to actually write it down. We have got that a equal to p minus u by t. Okay. Then we have got p equal to u plus at. Right. I will actually keep it in mind. We have to again use this. Okay. We know that velocity. Okay. Velocity have a formula that distance by displacement by time. Okay. If there is two velocity u and v. Okay, I told you when we are also discussing about the velocities, I told you that if the velocity is changing uniformly, that velocity is given by u plus v by 2. That is it is the initial velocity, it is the final velocity. Add them and divided by 2. Okay, so it is by s by t, and we have actually denominated as displacement by s because we need the s here. Okay. So now we will actually change some positions. We will keep s one side and t will be in the left side. So how it will look like that? Half u plus v into t. Right. So now we will something substitute. Keep u as 80s. We know that v equal to how much? U plus 80. Just right here. U plus 80. Okay. Now you keep t as it is. Now just simplify in the thing those things that are actually inside the box. What is going to be there? Ut. Again, there's going to be one more ut and plus a t square. Okay, ut, then again ut plus half of a t square. Now if you solve, you are going to get half ut plus ut. It is going to be twice of ut, right? Plus half of a t square. Simple. You cut 2 and 2. It is going to be ut plus half of a t square. Simple. Now you can write here that we have got s equal to ut plus half of a t square. Quite simple. Quite simple. Okay. This is the thing that we actually got. You just pause the video and write it down. Okay. Our next relation is going to be twice as equal to v square minus u square. This is nothing but the position velocity relation. Okay, what we have got, the speed as, or can actually write speed as the velocity as s by t, right? If there is two velocities u and v, that average velocity is going to be what? U plus v by 2. Okay, equal to, sorry, not 2, it is not t actually, it should be 2 and s by t, right? If you actually send something, what we are going to get? S equal to half of u plus v into t. Now it is going to be quite simple. We have got that a equal to v minus u by t. Okay, if from here we need the t will be what? V minus u by a. Simple. Just change the positions. Okay, now we will put this value here in place of t. That means we'll substitute the value of t as v minus u by a. If we just arrange it, what is going to be there? 1 by twice a. Okay. We can actually write u plus v as v plus u, and it is v minus u. In mathematics, you may have got one formula that a plus b into a minus b is equal to what? A square minus b square. Okay. Consider this formula as like that. P as a, u plus b equal to b. So what will be the relation? 1 by twice a into v square minus u square. But we need twice a as equal to v square minus u square. Okay. Simple. Just multiply it or cross multiply twice a with s. What is going to be there? Twice a s equal to v square minus u square. Simple, quite simple. Just pause the video and just solve it down. We have actually solved 3 relations without using graphical representation or graphic, okay, or graph. So now we will again solve this, use the graphical representation. Okay. Till now we have actually solved this thing. We will again solve, okay, now we'll again solve the equation of motion using graphical representation. Our first relation was v equal to u plus at. This is nothing but, again I'm just writing position. It is the velocity time relation. To solve this, we'll first draw one graph. Okay, one graph. And that graph I actually given in the last quiz competition. And I asked you to give the answer as the physical representation of the graph. The graph will be like a little bit like that. Okay. At the end of this video, I will in this actual discussion, you will understand what this graph actually means. Okay. Then you will be able to know your answer is correct or wrong. Okay. Just watch the video. Here I have draw one line. Okay. This is the O and this is the A. What this graph is actually meaning? That if it is time in second, here it is the velocity in meter per second. In this graph, we are not going to put any kind of values, right? We just need to prove something, right? We have to prove. So this is the point, and what this point actually means that at 0 second, okay, it has some velocity. That means what? From the point where we have actually considering the time, at that point, it is already in motion. That means at 0 second, it is in motion. Thus, don't get confused about this, okay? What this actually means that at 0 second, that means from which point we have actually considering the time. At that point, already the car is in motion, okay? And that motion is the initial velocity, and that motion may have some velocity, right? And that velocity will be u, okay? And after some time, okay, with uniform acceleration, its actually speed or velocity changes to v in b position. Okay. Now we have to prove this relation. So for that, what will you do? We will draw one normal in the x-axis. Okay. This is nothing but c. Okay. Again, this is actually nothing representing anything. Okay. Okay. It is actually representing a trapezium, right? So for our convenience, we will draw one normal again with dotted lines AD. Okay, this is the one normal AD we have drawn on actually BC. Now we have got our proper needs that actually with which we can actually prove this one. What we have drawn or what we have got that this OA has a value of equal to u, and this BC has a value of v. U is the initial speed and v is the final velocity, right? So what you can write? OA as u, initial, understand this, is the initial velocity, and BC as what? V is the final velocity, right? We have got. Again, what we can write? OC will be how much? T, right? So OC will be T. Again, AD is equal to OC, so it will be obviously equal to AD. Right? So we have got. Now, if we have to find out the this relation, we will actually apply some things that we can write BC as how? BD plus CD. Right? We can write this. So we got that BC as V. We don't know the BD. Again, we have got CD. CD is equal to what? We can actually write here. CD equal to OA equal to U. That means U. So what you can write? P minus U equal to BD. Give one equation number here. This is the thing we have got. Now, again we know that acceleration, I'm still representing it shortly. Acceleration is nothing but change in velocity by time, right? And from graph, what is the change in velocity? What is the change in velocity? What do you think? Change in velocity is nothing but the BD, right? Because this is the A point, okay? Till now we have velocity U, okay? And till now, here we have got the velocity V. So what will be the change? From this distance to this, it is the V. And from this to this, it is the U. So what will be the change? The BD portion. Okay, BD by T equal to A. Okay, now what will be the BD from here? BD equal to AT. Again, give two number here to second equation. From equation 1 and from equation 2, what you can write? We can write V minus U equal to AT. Simply you have got it. Now just arrange something. V equal to U plus AT. Simply I will prove it. V equal to U plus AT. Quite simple, right? There's nothing to actually worry about anything. Again, we will use the same graph to prove the next two relations. Quite simple. Just draw this and we will next move towards our next relation. Our next relation is going to be S equal to UT plus half of AT square. And this is the position time relation. Okay, we have to again solve this. It's quite simple. You can, if you use this, we can actually clearly solve this. See, in the last class, when we are actually just drawing the velocity time graph with uniform motion, acceleration time graph with or uniform acceleration, where you've got the velocity time graph. Here in that graph, it is kind of look like that. But the one difference is that graph started from 0. Now we have actually considered that from A. That means what? Here in this graph, U is not equal to 0. Just remember this thing. Right? We can actually see, since we are actually calculating the velocity in this y direction, so we have got some value as initial speed. That means what? U is not actually 0 because it is not starting from 0. So you can actually consider that U is not equal to 0. We will have to always keep it in mind. Okay. Now, I told in the last video when we were actually discussing about the velocity time graph, acceleration time graph, distance time graph, there when we need to find out the distance or displacement, we have to find out the area. Okay, under this curve or under this line. So if you clearly observe that this is nothing but a what? Trapezium. So what you can write from this graph, that S is, that is the distance or displacement, is the area of OA BC trapezium. Right? Simply we can write that the area under this trapezium will be the distance that is covered when it moves from A to B. Simple. Now, again we can actually divide this trapezium into two parts. Just clearly observe this. It's an ABD triangle. Again, there is one more rectangle ADCO, or okay, you can write OADC. Right? So what you can write? Area of, and this symbol is actually represent triangle ABD plus area of rectangle OADC. Now it has become quite simple for us. Just find the area of ABD. Half of the base is AD into what is the normal BD. This is the base, this AD, and this is the actually what? Normal. This is the formula, base into normal. Now, what is the area of the rectangle? This is quite simple. You can write OC into AO, or you can write AD into DC. Right? You can write AD into CD. Okay, from the last part we have got that AD is nothing but what? AD we have got T, right? BD we have got as equal to AT. If you just have any doubt, just rewind the video and you will actually got that how we have got the BD equal to AT. And again we are going to need CD. CD is nothing but what? U, because it is equal to OA. Since all the lines are parallel, that's why you can write CD equal to OA. So this is, it will be equal to this line because this AD is parallel to OC. Simple fact. Now we will just put the values here. Okay, just put the value of AD, it is the T. Put the value of BD, it is the AT. Now plus what we got, AD, T into what is CD, it is U. Now just rearrange it. We can write this one as 80 into T, it will be 80 square, and U into T, UT. Again rearrange it. What we are going to get? S equal to half of UT plus half of 80 square. Again we have proof one more relation using graphical representation of motion, right? Quite simple. Now again with this graph, again we can actually prove our last one. Okay, so you just pause the video and write this down. Now we'll move towards the last formula or last relation, that is nothing but the Poisson velocity relation. Okay, it is this part. You just pause the video and now you just have to rewind the video and write it down. Okay, our third relation is nothing but twice AS equal to V square minus U square. It's quite simple. Where U is not equal to 0. From graph, right? U is not equal to 0. Now, again simple, we need, here it is S. So we'll start from S. S means nothing but the distance or displacement, we can say. So what will be the distance? It is the area under this trapezium. That is, we can say area of, right? Area of OA BC trapezium. Okay, OABC trapezium. Now, what was the formula to find out the area of trapezium? The formula was half of, okay, half of addition of two parallel lines. Okay, OA, two parallel lines is OA and this BC is parallel, right, into the normal or the perpendicular line. You can say the normal or the shortest distance is the perpendicular line, that is the normal between these two lines, that is the OA and the BC, which is the normal OC, into OC. Now just we have to put the values. Now look closely, what is OA here? OA is nothing but U. What is BC here? This is nothing but T. And OC, sorry, not BC is T, BC is V, sorry. And OC is T. Now if I put the values and substitute the values, OA is U, BC is V into T. We have to arrange this because we need V square minus U square. So we have got that acceleration equal to V minus U by T. So just rearrange this, it will go to T equal to V minus U by A. Right? Now put the values of T here, right? Half of. We'll write this little bit actually differently, U plus V as V plus U. Quite simple thing. And T we have got V minus U by A. Right? We will again write 1 by 2A. This is nothing but V plus U into V minus U. In the latter part, we have actually, I have to give it a formula, A plus B into A minus B equal to A square minus B square. So it is V plus U into V minus U, it will be V square minus U square. So 1 by twice A, nothing but V square minus U square. So we have got that S equal to simple formula twice A into V square minus U square, right? So if you actually rearrange it and if we just we do cross multiplication, it will get twice AS equal to V square minus U square. You have solved all the three things actually, right? These are all three things we have to solve. you just pause the video and write this down, because these three are quite important. You are going to have 3 marks for this question, 1 mark for the actually figure, and 2 marks for the solving this part. So if anyone actually forget to draw this, you are going to get 1 mark less. So just be very careful. With one figure, you can solve all the 3 things. Okay, because acceleration, why? You may think that's all. Why only with one graph we actually is solving this? Because see, condition is same. Okay, there's only one initial velocity and the final velocity is v. Okay, so depending on this scenario, we have to solve the 3 things. Simple, na? There's nothing to be actually get complicated. Always keep your brain free from extra things when you are just discussing with physics. Just free your mind and you will get understand everything. Okay, but if you find any kind of difficulty, that if you not understanding any kind of things, okay, if I am just mistaking somewhere, just give me one comment in my video, then I will actually recorrect it in my next video. Okay, now just write this down. This is our last topic of this lesson, motion part 5. Okay, or you can see the motion lesson is going to end here. This is the end. And what this topic is, uniform circular motion. Till now, we have actually discussed the motion in a straight line. Okay, now we have to discuss what will be the motion or what will be the speed, right? What will be the distance in a circular motion. Now the thing is, in YouTube, because I actually follow YouTube, right? I have seen many videos where they have actually directly teach you draw a circle, and they will just teach you what is going to be the actually distance, what is going to be the velocity. That's it. This is the end of our lesson. But it's not like that. I don't think it's not like that. Since you have just get the physics for the first time, you need to understand from everything from the base. Okay, that's why my actually lessons part has become a little bit bigger. Okay, because I am just trying to give you some basic ideas. Okay, it becomes then easy. So now we will understand why the circular motion actually needed, right? From where the circular motion concept is comes. Okay, first observe that first we have learned the uniform motion or the motion in a straight line. We will first consider a closed part, not a circular part, closed part. Consider this as a circular part. That means closed part. Closed part means what? The whole part is closed. Okay, I will give some reading. A, B, C, D. Consider it has started journey from here. Okay, again like this, and like this. Okay, this is the closed part. Now, if I ask you in this case, what is the distance it traveled? It is this must be the distance, right? This is nothing but what? This is the perimeter of this rectangle, right? So we can actually find the perimeter. Then we will actually be able to calculate the distance, and displacement will be 0. If it again reaches here from again it starts from here, again it ends here, the displacement will be 0 because the starting point and the ending point is at the initial point and the final point is same. Then the displacement will be obviously 0, but we got some distance, and from that you can actually calculate the speed, right? And one thing always remember, whenever we have to calculate the velocity, okay, if there is no direction, we have to mainly consider the magnitude. That's why we will consider the distance is not 0 here, because we need the magnitude. Now, if I again increase the part, right? This is AB part, BC part, CD part, and AB part. There's only 4 parts. If I again increase part like this, A, B, C, D, E, F. Again, it has, made a journey like that. This is 1, this is 2, right? This is the, what? Rectangle. This is what? Hexagon, right? Now, what actually happened? It is again a closed part. Now the branches are bigger in number. That means the parts are bigger. That is AB part, one part, 2 part, 3 number of part, 4, 5, and 6. That's why it is a hexagon. There are almost 5 parts. Okay, and there is change of direction in 1 position, 2 position, 3 position. That is almost in 6 parts. That this direction is going to change. This is the thing. Again, we are going to get the perimeter of this hexagon. Then we will be able to find the distance, right? Now we will again increase the number of paths. It will be like this. sorry, let me draw properly. Okay, this is 1 point. These are the points where the distance actually changed. Now calculate the number of actually branches. A, B, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Okay. A, B, C, D, E, F, G, H, I, J. Now you can clearly see that their number of branches are almost 10. Okay, number of branches means number of paths are almost same, almost 10, right? So again we have to same case like that, we can actually find the perimeter, then we can find the distance. Now look closely. Is this figure almost looking like a circle, right? So if we give some dotted lines like that, again if I draw here, this circle will completely look like that. Though it is not a proper circle, since I have drawn with my free hand, just consider it as a circle, right? Now what is actually happening? Those part land, right? Those part land now becomes what? A certain point. Have you understood what I've said? Because when we actually accumulate number of points at a certain distance, then we get a circle, right? This is the path length AB, this is again path length, this is again path length, this is again path length. Now we have just we did what? We just decrease the path length from this, has some decrease in path length from this. Again, this is again have, since I have a little bit draw it bigger, it just look like same. But again, if I draw in a small amount of area, this path length will be smaller than this. Okay. If I again draw a circle, this path length will become a point. Okay. Billions of points are there. Billions of points are there. And with this, we can actually draw the circle. That's how the concept of uniform circular motion or the circular motion comes. Okay. Uniform circular motion means what? That velocity will remain constant, but its direction will change, right? And its speed will remain same, its magnitude will remain same, right? This is the main thing. Okay, now consider that this is the starting position A, right? If I consider that a car moves in a circular path and it's covered this distance and this journey again here, how much distance it is actually covered? And that distance will be given by what? Simple. What is the distance? The distance will be the circumference of this circle. And how it is represented by this circumference? That is nothing but twice pi r. Simple. And if there is no value of pi is given, you should always write pi's value as 22/7. Now we have to calculate the velocity. Velocity is nothing but what? Displacement by time. Now displacement, or you can say consider the distance. It will be how much? Twice pi r upon time. Because this is the main actually formula to find the velocity in a uniform circular motion. Clear? Clear, na? Quite simple. Quite simple. Nothing to be get worried about. This is the way how we actually move towards the concept of the circular motion and uniform circular motion, that you can say anything, right? So this is the end topic of this lesson, motion. Okay, I will have actually think that you have understood the things. I have must give my best, okay, to make it simpler everything. Okay, if you still find some kind of difficulties, ask me in the comment section, then I will clear your doubts. In the next part, we will solve problems depend on the whole lesson. Okay, I will try to solve at least 5 to 7 problems, because in limited amount of time it is not possible to solve lots of problems, right? I will try. Okay, I will give my best. I will move faster in that video and I will solve many problems. Still, if you get some kind of doubts, just tell me. Okay, this is the time. Now this is now the time to actually give you the answer of this my last quiz competition question, and with that I will actually announce the names. Okay. Now, just first you just write this down or draw this down. Then I will move towards the next part of this video. That is nothing but the winner's name released, and I will first give the answer of this question. Okay. This is the question that I have actually asked in the last part of the video, that give me the physical significance of this graph. Okay. Now look closely in this graph. Today I use this graph in solving and in actually proving those equations of motion using graphical representation, right? I have told in the earlier part of this video. Now many students have given me answers, okay, but only from two students I have actually got the proper answer. And since we are mainly now dealing with the concepts, please don't mind, I will only consider these two answers. Okay, that's why I have told you that we will now move towards some actually difficult parts, okay, where we actually mainly discuss or mainly deal with concept. Okay, so that's why I try to understand the concept. I told you that though it is a velocity time graph, it is actually meaning that many students actually replied that this is a uniform velocity type graph or uniformly accelerated graph where the velocity sense is actually not actually proper, velocity sense is uniform with time, right? This is a correct answer. This is, you can say, almost 70% correct answer. Okay, but I told you, if you can give me 80% correct answer, it will be 100 for at least almost 100% correct answer for me. But the main significance is not that. Okay, many students have actually forgot one thing, that this part. Now look closely here. We got that at 0 second, we have got 20 meter per second. We have got at 0 second, it is already having a velocity 2 meter per second. Right? Only two students have mentioned this thing, that at 0 second, okay, it is already having a motion that is 20 meter per second. Right? That means what? The car, when it senses its velocity from this to this point, okay, consider this as a point A and this point, this B. Okay, when it sends its velocity from A to B position or velocity, before that it was actually having a velocity how much? 20 meter per second. So you have to look closely. Okay, in some many graphs I have drawn the velocity time graph as like this. Now this is velocity, this is time, like this. In this case, at 0 the velocity used to have 0. But in this graph, at 0 second, okay, you consider at 0 hour or whatever you want, at 0 second it is having velocity, already having velocity. That means what? The car is already in motion. Okay, and its initial velocity is u equal to 20 meter per second. Right? So this is the main correct answer. Okay, yes, there is one fact that it is in uniform accelerated motion or uniform velocity. Right? Velocity is changing properly with time. It is a uniform accelerated motion. This is correct. The main thing, if I need only that answer, I would have given the graph from 0. Since I have given the graph from a certain position where it has some value, then you have to actually think like me. Why should I only have given or draw the graph from here to here? Okay, so today I will again put some question for you, only one question. You just think deeply. Okay, then give me the answer. Don't just do not be a hurry up guy. Okay, first watch the video properly, then understand the question. Once I give the question, you just note it down in your book and try to actually understand it. Okay, you will get almost 2 days to actually give me the answer. Clear? So now we'll announce the name of the two students. Okay, but don't actually feel bad if you have tried your best, but you just mistaken actually this part. So congratulations to all of you who have actually answered, because I always say that try your best. So, and I always believe that trying will make you perfect. Okay, so next time try your best, and next time I will answer correct answer from everyone. Okay, I think you will be able to do that. Okay, now I will just announce the names. The first answer, correct answer, was given by one boy. His name is Diptangsu Oleman. A big congratulations for you. Okay, he had said that, sir, the graph represents a uniform velocity. As we can see that the graph represents a straight line, which means that the velocity is increasing uniformly. Correct, right? But its initial velocity isn't 0. That means what? At this point, u is not equal to 0, right? Here, actually got a correct point. That is, its starting velocity is more than 0 and it catches a uniform velocity from 20 meter per second, right? That means what? It is the initial velocity. This is the final velocity, right? So, this is the correct answer. And there is one more, maybe a girl who gave me a correct answer. Okay, her name is Amanjita Rahman. Again, big congratulations for you, Amanjita. Okay, that she has said that the graph is a uniform velocity because the graph represents a straight line and the velocity is increasing at a constant rate. Obviously correct. What does it mean? If acceleration is 2 meter per second, right? If acceleration is 2 meter per second, that means the velocity will change at a constant rate. That is 2 meter per second, 2 meter per second, 2 meter per second, right? Should be, sorry, this is actually 2 meter per second square, right? So this is the concept actually I have given a last part of the video. Okay, straight line and the velocity is increasing at a constant rate. Yes, since the initial velocity is not 0 but 20 meter per second, right? Again, same concept. Hence, its starting velocity is more than 0 and it is a uniform velocity. This is the concept. So, the winners are mainly one girl, Amanjita Rahman, and the second one is Diptangsu Oleman. A big congratulations to all of you that who have tried. And again, big congratulations to these students, Diptangsu Oleman and Amanjita Rahman. You have tried your best, right? That's why you are just able to give the proper answer. So, it is my kind request to all of you that you will be able to give again. Okay, now in the next video, maybe you are the winner. First, I always say that try to grab the concept, okay, from this graph. What you can actually get from this graph, what information you can actually get from this graph, right? Then just try to answer. Use your brain, okay? Try different ideas. Draw it in your copy, then just try to give the answer, okay? Then you'll be able to do the answer. It is my 100% assurance to you. Okay. Now we'll move to our today's question. This is the today's quiz competition question. Look closely and write it down in your copy. Now, what is going to be the question? Now, what is the question actually saying? That 4 cars A, B, C, and D are moving in a level straight road. Okay, that means this is the straight road, right? Their distance time graphs are shown in the figure below. This is the distance time graph of their actually of those cars. Now, the question is find the correct statement. Okay. So, from this, you should find the correct statements watching this graph, okay? And you have to give the answer with proper reason. Now, first you write this question in your copy, then analyze this, okay? This time, I am just assuming that all of these students will be able to give me the correct answer. For your benefit, I have given you the actually options here, okay? Proper graph, proper labeling, okay? Just write this down in your copy and give me the correct answer. Okay, and in the next video, I will announce the winner's name of this quiz competition. Till then, you have the time to, actually today is 19th May, right? You have time of 2 days. That means on 21, 5, 21 till 6 p.m. you have the time. Okay, 21, 5, 21 till 6 p.m. you have the time to give me the answer. Till then, think about this. Okay. Okay, not 21, not 21, sorry, it will be 20, it will be 20, okay, 25, 21, okay. So, give me the answer before 6 p.m. on 25, 21, that means 20th May, okay. Try your best and all the best to all of you. Just stay safe because of the, the corona situations are everywhere, okay. Lots of people are dying. Okay, so it is better that you should keep yourself safe. Okay, then your family member will remain safe. Okay, tell this to your family too, right? That everyone should actually stay safe. Use your sanitizer. Use proper mask if you have to go outside to buy some stuff. All right, till then stay safe. Okay, study properly. Watch the video attentively. Don't skip anything. I know that lots of students are skipping these videos. Okay. I know that it is not quite possible for anyone to watch the videos with for this length, but try to watch it because otherwise you won't get some concept. Okay, those students who are watching the videos again and again, they are actually now able to give me the correct answer. In the last quiz competition, only 2 students give me the correct answer. That means what? They have watched the video and understand the video very well. So I am just hoping that you will now watch this video again right, again and again, then you will be able to give me the correct answer here. Okay, so till then, stay safe. Okay, be healthy, right? So bye bye.